At Something Research Center, NASA uses its large something to test the effect of very large accelerations, blah blah blah. In this device, an arm 8.84 meters long rotates about one end in a horizontal plane. So we know it is a centripetal force problem, and we don't have to account in gravitational force and normal force. An astronaut is strapped in at the other end. Suppose he assigned blah 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 blah. It's typically 12.5 g. How fast must the astronaut's head be moving to experience the maximum acceleration? So the centripetal acceleration is given by v squared over r. And v could also be equal to angular speed times the radius. So we could substitute this into angular speed squared, radius squared over r, which equals to angular speed squared and r. So we know that the centripetal acceleration is 12.5, so we set this to 12.5 g. And for this part, we just calculate for omega and then multiply it by r, I guess. So if we were to rearrange the equation, we would get omega equals to 12.5 g divided by r square root. And if we were to plug that into a calculator, we would get 3.76 rad per second. And since v equals to omega r, we just multiply this by the radius. 3.76 times 8.84 equals to 33.24 meters per second. And that is for part A. And now for the part B of this problem. What is the difference between the acceleration of his head and feet if the astronaut is 2 meters tall? So his feet would be right here, and his feet from the center of the rotational motion will be 8.84 minus 2 equals to 6.84. And like we calculated in the previous problem, omega equals to 3.76, and angular acceleration like we derived is omega squared r. So the acceleration of the feet equals to 3.76 squared times 6.84, which equals to (96.7 meters per second squared). And since we know that the head has the acceleration of 12.5 g, we subtract them both. So 12.5 g equals to 125 meters per second squared. And 125 minus 96.7 equals to about 28.3 meters per second squared. And that is the difference in acceleration between the head and the feet.